So continuing on with our requests from the class, today I want to talk a little bit about the Euler equation. Right? Remember that my Euler equation always takes the same functional form because we're always working with the same two-period choice model, which looks something like this, right? We have some utility function of C1, C2, which we're trying to maximize, and we're trying to maximize that with respect to a budget constraint that looks like this, right? The idea being here, right, this is my savings, my Y1 minus C1. So my consumption in period 2 is equal to what I save plus the interest on my savings, or the interest on my debt if savings is negative, and then my income in period 2. I can need to differentiate this with respect to the chain rule because what we really have here is C2 as a function of C1, right? These things are connected through the budget constraint. So if I want to think about the effect of C1 on C2, I have to incorporate that budget constraint when I differentiate. So when I differentiate here with respect to C1, right, I get two things. I get the partial derivative with respect to C1. That's what I've been calling the direct effect. When I buy more C1, I get the value of consuming that C1. Extra C1 today increases my utility, but then I have to think about the effect on C2, and I have to think about how that's influenced through the budget constraint, right? I have this direct effect, and then I have this indirect effect, where when I get this extra C1, I have to think about how much C2 I'm giving up, and then how much that C2 hurts, right? This is my C2 sacrificed to get that C1, and then this is the pain of losing C2. So hopefully that makes some economic intuition, right? And then because we're maximizing, we're always going to be setting that equal to 0, and so I always get an Euler equation of the exact same functional form. Right? Let's make that a little bit concrete with some examples. So if I think about my utility function as looking something like this, we can differentiate, right? And if I differentiate, I get something like this. So here I've done two things. One, I say, well, the change in utility with respect to C1 is equal to the direct effect of increasing C1, and that's valued proportional to the change in that square root function. Then I have to give up C2, but then the amount of C2 I have to give up is always equal to this DC2, DC1 term. But this DC2, DC1 term from my budget constraint is always 1 minus 1 plus R. Right? Now, again, that's assuming this perfect financial market stuff we've talked about a little bit before. But in general, when we're doing this with calculus, we haven't worried about solving the model algebraically with imperfect financial markets, only graphically. When we have imperfect financial markets, the other equation might not exist because we can't optimize smoothly, right? There are kinks and sharp edges in the budget constraint, and that sort of stuff doesn't work well with differentiation. So here I get something that says, look, I get my Euler equation, marginal utility 1. This is my marginal utility 1. This is my marginal utility 2. Utility 2, 1 plus R. And that's the functional form that's always going to come out of these things, right? If I try a different functional form, U equals C1, C2, and I remember that C2 is a function of C1 through the budget constraint. When I take my total derivative here, I get something like C2 plus C1 times minus 1 plus R, which again, when I set this equal to 0, it gives me C2, 1 plus R, C1, marginal utility 1 equals 1 plus R, marginal utility of 2. Always comes back to the same thing. And so when you're doing macro, or even when you're doing micro, you tend to see this expression over and over again because it makes so much intuitive economic sense, right? In a simple world where interest rates were 0, we would set the marginal utility of consumption equal to each other in each period. If we weren't doing that, you could reallocate consumption from where it was less valued to where the consumption was more valued. But in a world with interest, we need to put our finger on the scales just a little bit. It doesn't make sense to set the marginal utilities equal anymore, because if we set the marginal utilities equal and interest was positive, now it makes a little more sense to save and earn the interest to and make yourself a little better off like that.